In this video, I'm going to show you guys how to calculate the molar mass of a compound. When we're calculating the molar mass, we use mass numbers. If we look at an example here, we have carbon. Carbon is very popular with our organic compounds, so I'll just use carbon. When you look at carbon in the periodic table, there's two numbers. There is a small number, it's called the atomic number, and then there's a bigger number. And the bigger number is called the relative atomic mass. Okay, so when we're calculating molar masses of compounds, we use the relative atomic mass number. And then we also use the formula. So we need to know what butane, for instance, looks like, what butanol looks like, and what butanoic acid looks like. Okay, so butane, because it's has 4 carbons. Okay, because it's butane, alkane, there are no double bonds or triple bonds. There is just single bonds all around. So this is butane. If we write it in the molecular formula format instead of the structural formula, we find that there are 4 carbons and there are 10 hydrogens. Okay, so what this means then is in each butane molecule we have 4 carbons and 10 hydrogens. And if we look at our periodic table, carbon's atomic mass is 12.01 and hydrogen's atomic mass is 1.01. If we multiply and add these two values, we have 48.04, and on this one we have 10.1. Okay, adding these two up, so these two added together, we get 58.14. This is the molar mass for butane. Butanol looks very similar to butane, except one of the hydrogens is replaced with an OH. Okay, so the formula will be very similar. If we count the hydrogens, the carbons, and the oxygens, we get 4, and hydrogens we have 10, and there's an oxygen. So again here we're going to have 4 times C, 10 times H, and 1 times O to give us 48.04 again and 10.10, and the last one will be 16.00 because the molar mass or the relative atomic mass for oxygen is 16.00. So when we add these two up, we get 1,4 here and we get 4,7 here. Okay, so this is the molar mass for butanol. Okay, the last one is butanoic acid, and butanoic acid also has 4 carbons, but the last carbon has the alkanoic acid functional group. So the formula for butanoic acid comes down to 4 carbons, and then hydrogens we have 8, and then oxygens we have 2.